Welcome back to the groundwork. So it's been a while since I've done a straight DIY video, and that's what this one is. We're going to be bracing up the front axle housing of a GU Patrol. Now I have done a video before on doing this job, but it was for my race truck, and it was a bit of a weird video. I didn't talk in it or anything like that. It was no way a DIY video, and yeah, it was all custom and everything, so it wasn't really applicable to most people, so not a DIY video. But this one is. This is a housing I'm bracing up for a friend, and they supplied me with an off-the-shelf bracing kit. This one's from Roadrunner Offroad. It's a really good kit. It is my preferred kit to use in this sort of application. Now, before I actually get started with bracing the diff, we need to assess the condition of the diff itself. So there's a few things you can do to check that it's even a candidate for being used, like it hasn't been bent previously. They're by no means completely accurate, but they do give you a rough sense of the condition of the diff, and if it's a bit wonky, then you can send it off for proper testing. First thing I do is I'll take my digital angle finder, zero it out on a flat section of the diff, and I do choose a few different spots. Like I'll do it here, I'll do it on top of the coil hats, and yeah, so anyway, so we zeroed it out. Then we just got to lay it across the kingpin races, and if it's within 1 degree of each other, to me, that's a straight diff. And what this one is, yep, so cool. We can actually get on with doing the work itself. Now, this thing, I'm going to have painting it as well, so I'm going to have to give it a really good clean up with a wire wheel before we can get going with anything. This bracing section here is going to be sitting on top, so anything that's on top of the diff here we need to cut off, just our brake line bracketry and things like that, and we'll be reattaching them after the job is done. Now, another form of damage you want to check out before you go ahead and brace your diff is to actually see if the knuckle balls are towed in or towed out. Usually in a front ender, they'll end up towed out. So you can measure it, but a better way of doing it, just by eye, is actually looking at the condition of your radius arm mounts and seeing if they are straight. Now, if they are, you know that you're probably going to be pretty good, because the thing is, if you've done the kind of damage to the diff that means that the knuckle balls are bent out, no doubt your actual radius arm brackets will be damaged themselves, they'll be all dog-legged and cockeyed. So if they look straight, then generally you're good to go. I've just got this cover plate that I use for trying to keep the disc sealed a little bit, try and keep all the debris out while we're wire wheeling it. Goes on a painful cleaning job later. That was fun. Right, well, the first job I want to do is add the hole reinforcement to the radius arm mounts. Sometimes this is done preventatively, sometimes it's done to repair holes that are flogged out. In this case, it's to repair holes that are flogged out. So you can see how those holes are elongated. That's just from movement of the diff and the bolts maybe not being tight. So what we do is, the kit's supplied with these laser cut washers, and they get welded on to essentially give a proper hole center and add reinforcement. Right, well, we can't just go weld them on willy-nilly. We need to make sure it's aligned, not only with a bolt through it, but the correct spacing for the radius arms and the actual right alignment. That's why the only way that you can do this properly is actually with a radius arm bolted in it and checking that it is in the right alignment. Thing is, you might jag it, but the reality of it is the very least of the problems that you can have is that if you weld them in the wrong spot, it'll be hard to line your bolts up when you're putting it back in the car. The worst of it actually is that you're just going to flog bushes out. So it is important to actually make sure that they are correctly aligned. So I've got a couple of radius arms here, and I'm going to bolt that all up together, make sure that they're all nice and lined and everything like that before I weld them on. Okay, so next part I want to move on to is the radius arm gussets. So that's just like a little piece that goes in there, and we point it at the radius arm bolt because one of the places that these things do bend is actually through the radius arm bracket. So that's like a nice little thing to address that. We'll just weld it on those knuckle gussets, so I'm just waiting for them to cool down before going to the next step. So I was going to start looking at the pumpkin guard. So put you down here. So that's what we're working with there. So the deal with these is like, you weld on, bash, weld and bash it down, and just bash it around and keep on welding. But because I've got the press brake, I'm actually going to fold it so it follows the radius, so we don't have to do any bashing. Well, I got pretty close. It's actually quite nice. A little bit crap through where my finger is there, but it's okay, I can bash it into position. And I want that to not be centralized, sort of down a little bit, just so we can protect that sort of leading edge of the bottom of the pumpkin there. So now I'm getting towards the business end of things and really got to start thinking about the heat that we're putting into it. So at this point, I like to actually put the third member in. And I mean, if you got your third, you just put it in. But like I've got an empty one that I keep doing this job. A bit easier, being a bit lighter. I've done the first of my stitches. And now is when you've got to be patient. You've got to do those 2-inch stitches and you just got to let the thing cool down and then come back to it. You know, it's so tempting to just get in there and get it done, but you just got to chill and just let it cool down. So this will probably be like 3 or 4 sessions to fully weld that truss on. So I'm just going to leave that now, go inside, have some dinner, maybe do one more tonight and then just finish it off in the morning. Okay, so while the dogs and the diff are out there baking in the sun, just a few final tips. So you might have noticed that like I didn't strap the diff down or anything or have it in a jig, because you don't need to. You just got to control the heat and think about where you're welding and how you're going about it, sort of thing, you know. I know that's not true of all diffs, but Patrol diffs, you don't need to. I've done a ton of them and I've never bent one. You know, like I said, it's just about controlling the heat. So another thing you might have noticed is that the sound of the welder is changing all the time when I'm welding different things on, because I'm changing the settings all the time, because I'm trying to keep as much heat out of the diff as possible, and only like really cooking it where I need to. Say for example, like the drain bung, like when I'm welding the ring around that, that's like a, you know, full penetration, nice hot sort of weld, because that's going to cop a lot of abuse and they're thick materials. Whereas the truss itself, it's thinner material and I really don't want heat in there, because there's a lot of weld across a span that could pull the diff out of shape. We don't want that to happen. So I like dial the wire feed back, dial the voltage back a little bit, and just concentrate on going a little bit slower, a bit more of a weave pattern, and so it doesn't get super hot. And it all works, all those things combine to get you a good result in the end. So it's a straightforward job. It's a common job that people want to tackle these days. So I hope that you get a bit of information out of this that will make it a bit easier for you if you are going to do that job, and a bit more confident that you'll get a good result. So see you in the next one.